Whiz kid with a very powerful idea.
This wire takes the energy from the air. Down below here, we turn it from AC into DC.
Right there on the 7th, this is Swisscom, their radar imaging, and look at the density starting to build right here.
Max Laughlin.
Yes, every time an electron moves an atometer, you're shot into an infinite number of parallel universes.
Celebrated as one of the brightest young minds, disappeared from the public eye amidst fascination over his invention capable of converting air into energy. Drawing inspiration from renowned scientists like Tesla and Einstein, his intellect was widely admired, raising questions about the pressure he faced. Now, his unexpected return has sparked curiosity, with claims of proving the reality of his inventions. However, his reluctance to disclose the full extent of his knowledge, learned from his alleged captors, fuels speculation. Join us as we investigate Laughlin's reappearance, revealing how it may reveal unsettling truths we wish had remained concealed. The theoretical and practical worlds of Max Laughlin. Max's concepts, such as transforming ambient atmospheric energy into power through a wire, ignited imaginations. He spoke of converting AC energy captured from the surroundings into DC power, using terms and references that echoed the work of famous physicists. Alongside references to historical figures, he included modern scientists, presenting a blend of past and future that seemed too good to be true. Despite the initial excitement, Laughlin disappeared from public view, leading to speculation about the impact of early fame and intense public scrutiny on young talents. His absence left many wondering whether the pressure had become too much. Now, Laughlin has returned, claiming he's ready to transition into the real world, a statement that suggests he wants to prove that his early work was more than just child's play. What was Laughlin doing during his time away from the spotlight? Details are vague, and his explanations lack depth, often feeling more promotional than substantive. He claims to be gearing up for a comeback, reiterating his commitment to his scientific pursuits. However, the validity of his past claims remains under a cloud of doubt. How much of his fame was based on real scientific achievements, and how much was built on the fascination with prodigies? As Laughlin attempts to re-establish himself, the public and scientific community remain skeptical. His early work, wrapped in the promise of revolutionary insights and transformative technology, often resembled a well-crafted story rather than a clear scientific advancement. His discussions about CERN and theoretical physics straddled the boundary between innovative thinking and speculative fiction. Now, as he re-enters the public sphere, it's crucial to evaluate his contributions critically. Will Laughlin's return bring the significant scientific advancements he once promised, or will it prompt further questions about the practicality and authenticity of his work? The challenge lies in discerning whether his theories can be applied in real-world scenarios or if they are just theoretical musings. This new phase in Laughlin's career is a test of his ability to transform his early theoretical ideas into real, tangible outcomes. Can he move beyond the shadow of doubt cast by his abrupt disappearance and past controversies? The answers will not only impact his future, but also shape how young prodigies are perceived and supported in their scientific endeavors. As Laughlin steps forward, the focus should be on tangible results and clear evidence, moving away from the spectacle and towards genuine scientific contribution. Max Laughlin is often celebrated as a young genius, gaining a lot of attention in circles that value youthful talent, though the praise can sometimes seem more about excitement than serious evaluation. From an early age, Max showed a deep interest in science and technology. He was able to understand complicated scientific ideas faster than most kids his age. He first became famous for his big ideas, like a machine that could create free energy, and his theories that connected the Mandela effect to CERN, ideas that, while they grabbed people's attention, also made some question their credibility. After briefly disappearing from the public view, Max returned, sparking renewed interest in both his personal story and his academic pursuits. As a child, Max loved to take apart gadgets. This wasn't just for fun. He was driven to figure out how they worked inside. By the time he was in elementary school, his interests had grown to include renewable energy and the larger questions about the universe, suggesting he was always destined for big things. During his last year of high school, Max really stood out with his school projects. He worked with a classmate, Luke Jansen, on a special project using photogrammetry to make 3D models of ancient rock carvings in the Valley of Fire State Park. Even though they ran into problems with their equipment, Max showed a kind of toughness that could be seen as either a true sign of a future scientist or as a well-timed show of strength when facing challenges. His project wasn't just about studying. It aimed to use digital technology to protect, and perhaps commercialize, ancient artworks on a worldwide scale. Max's careful attention to detail and his methodical approach to work are often praised, but they also lead to questions about whether he's looking to turn cultural heritage into a business opportunity by presenting it as conservation. His work is certainly creative, but sometimes it seems to walk a fine line between adding to scientific knowledge and using flashy tech to gain more fame. This balance between real scientific research and the pursuit of recognition through controversial ideas is something Max seems to handle with both care and ambition. As Max continues to advance in his field, both supporters and critics keep a close eye on his methods and the early theories he proposed. Discussions about his contributions are often divided, showing a common pattern in how we support young talents in science, sometimes focusing more on creating a fascinating story than on careful, critical examination. In this way, Max's story reflects our broader interest in young geniuses. His future will likely be marked by both praise and critical reviews, challenging him to prove that his early signs of brilliance can develop into consistent, reliable scientific work. Looking ahead, it's likely that Max's path will remain a topic of public interest, blending admiration with skepticism. How Max manages this balance will be crucial as he tries to cement his place in the scientific community. This ongoing narrative not only shapes his personal growth, but also influences how we think about and support emerging talents in the sciences. Next, Max enters a new university adventure, filled with dreams and challenges. The sudden silence of a promising scientist. As Max neared the end of his high school days, his future plans began to take shape, driven by his keen interest in physics and engineering. Like many ambitious students, he was drawn to the idea of furthering his education in these popular fields. His hard work paid off when he was accepted into the University of Wisconsin-Madison, a decision that seemed almost predictable given his academic record. At university, Max planned to dive deeper into physics and engineering, aiming to contribute something new to these crowded areas of study. He wanted to be at the forefront of scientific innovation, although reaching such heights is quite challenging in the competitive world of science. Before he even started college, Max was deeply involved with particle physics and renewable energy. His early experiments and studies focused intensely on understanding the basic forces of the universe and finding new ways to use sustainable energy. This was not just a passion, but an obsession, as he spent countless hours in the lab working on ideas that could change how we think about and use energy. Max believed strongly in the need for clean and sustainable energy sources. This belief was noble, but it also seemed a bit idealistic. He seemed to think that his efforts in the lab were crucial for the planet's future, aligning his personal goals with the global narrative of environmental sustainability. Transitioning from high school to a prestigious university was a big step for Max. The University of Wisconsin-Madison provided an exciting but demanding academic setting. Here, Max was expected to keep up and stand out as a future leader in his field. However, this environment also highlighted the competitive nature of scientific research. The push to make new discoveries and gain recognition can overshadow the collaborative spirit of science. His dedication to pushing scientific boundaries and making a meaningful impact was admirable. Yet, it also reflected the intense pressure and competition that young scientists often face. Max's story is one of personal commitment and the broader challenges of striving for excellence and recognition in the scientific community. In navigating his university life, Max was constantly balancing his ambitions with the practical realities of scientific research. His days were filled with studies, lab work, and the ongoing challenge of proving his theories. Each experiment and project was a step toward his goal of becoming a notable figure in the world of science. This drive to excel and contribute to scientific progress made Max a typical example of young, ambitious scientists today. He was not just pursuing knowledge, he was also chasing the prestige that comes with major scientific breakthroughs. The world of academic science is as much about forging a career as it is about expanding human understanding, and Max was right in the middle of it, working tirelessly to make his mark. Max, once celebrated as a bright newcomer in the fusion of physics and engineering, had made a name for himself with innovative prototypes that could potentially transform energy technology. His groundbreaking work captured the attention of both academic circles and the energy industry, placing him as a key figure poised to make significant contributions to his field. Suddenly, Max disappeared from public view. His sudden absence sent shockwaves through the academic and industrial communities that had once supported his rise. The projects he had been working on came to a screeching halt, and his colleagues were left scratching their heads, trying to piece together any clues that could explain his sudden departure. Various theories circulated, from the pressure of his newfound fame being too much for him, to him possibly undertaking highly confidential research away from the eyes of the media and his academic peers. In his absence, discussions about his whereabouts and state of mind became more common than ever, with every acquaintance and distant colleague speculating about his potential activities and well-being. A video, released by his high school from a senior passage presentation in 2023, showed him alive and well. In the video, he discussed his departure from high school, sharing the mixed emotions of excitement and anxiety as he transitioned from being a student to what many expected would be a trailblazer in the scientific community. What had Max been up to during his time out of the public eye? Had he gained new insights? Or was his disappearance just a break from the overwhelming pressure and exposure that came with his early success? His peers and the wider scientific community were eager for answers, their initial worries about his well-being calmed by the sight of him speaking at his alma mater. Yet, despite his return, many questions about why he left and what it meant for the future of his projects lingered. The buzz surrounding his return was as intense as the discussions about his absence had been. Everyone was eager to see what Max would do next, and whether he would continue with his previous projects or take a new direction. The intrigue surrounding his time away provided plenty of material for discussions, but now his return promised even more speculation about his past decisions and future plans in the rapidly changing world of energy and engineering. As the community watched and waited, Max's next steps were anticipated with both skepticism and hope, signaling a potentially new phase in his career. After a sudden disappearance, Max returns with stories that spark curiosity and concern. Max Laughlin's pursuit of the impossible. During his speech, Max shared his experiences from a senior project where he and his classmate, Luke Jansen, attempted to create 3D models of ancient petroglyphs at the Valley of Fire State Park. Their task, while it sounded exciting and educational, was bogged down by several mundane problems, like delays in getting their equipment and the lack of Wi-Fi at their campsite. They also faced the tough task of converting many photographs into accurate 3D models. However, Max described these issues as if they were dramatic and critical challenges, emphasizing how each problem helped them grow in determination and problem-solving skills. Max enthusiastically explained how these hurdles were actually opportunities for him and Luke to think creatively and keep pushing forward. He spoke about how these experiences taught him to view difficulties as chances for growth, claiming that his school years had prepared him well for facing and overcoming future problems. But listening to Max, one might wonder whether he was overstating the impact of these challenges. Describing a Wi-Fi outage as a significant obstacle suggests a somewhat privileged perspective, where small inconveniences are seen as major hurdles. This portrayal could make one skeptical about the depth of his hardships, and whether they were truly transformative or just typical issues blown out of proportion for the sake of a good story. As the session moved into a Q&A, Max continued to stress the importance of tackling challenges head-on, stating that this approach was essential for personal and professional development. However, this stance seemed to echo a kind of youthful overconfidence, where Max viewed himself as ready to take on the world without perhaps having faced truly testing conditions. Max's tendency to dramatize his experiences might make his narrative compelling, but it also raises doubts about the realism in his outlook on life's challenges. It appeared that he was using his project story more as a platform to celebrate supposed victories over adversity, rather than offering a grounded or critically reflective view of his experiences. Moreover, Max's recent unexplained absence, which was briefly mentioned in a video, added an element of drama to his already polished presentation. The video hinted at his interest in developing groundbreaking technologies, but it also seemed designed to keep the audience hooked on his personal saga rather than delve deeply into his professional aspirations or personal growth. Overall, while Max aimed to inspire his audience with stories of overcoming adversity, his recounting felt a bit crafted to showcase an ideal version of resilience. It seemed to oversimplify the nature of real challenges, presenting them as neatly resolvable issues rather than the complex and often messy realities they are. His approach may inspire some, but to others, it could seem as though he was not fully acknowledging the true nature and unpredictability of real-world problems. Max Laughlin's project to develop a free energy machine appears more like a flight of fancy than a serious scientific endeavor. He claims his machine can harness energy from abundant sources like solar and wind power, along with the more obscure quantum fluctuations. While the idea of a device that could eliminate our dependency on fossil fuels is undoubtedly appealing, there are significant doubts about whether such a machine can really deliver on these promises. The concept of a single device transforming our energy landscape is an old dream that many have pursued without success. Max's vision includes not just creating a sustainable energy source, but also fundamentally changing how we power our world. However, the real-world applicability of his designs remains to be seen, as they are still in the conceptual phase without any proven results. Alongside his energy machine, Max has shown a keen interest in the Mandela effect, a phenomenon where large groups of people remember an event differently from how it actually happened. He suggests that this might be tied to complex ideas in physics and could possibly indicate the existence of alternate realities. According to him, certain quantum events could cause overlaps between parallel universes, leading to these collective memory discrepancies. His connection between the Mandela effect, quantum mechanics, and the concept of multiple universes may seem compelling at first glance. Yet, it could also be viewed as an inventive story crafted to draw attention. While the idea of parallel universes is discussed among physicists, using it to explain differences in human memory is quite a stretch. It appears Max may be leveraging the popular fascination with quantum physics to lend credibility to theories that lack solid evidence. Furthermore, if Max's theories were proven accurate, they could revolutionize our understanding of reality itself. However, his ideas are presented in a manner that seems more suited to sparking curiosity than undergoing the rigorous scrutiny of scientific testing. This approach raises questions about whether his work is aimed at pushing the boundaries of scientific knowledge or simply providing an intriguing topic of discussion. Max's activities, from his proposed energy solution to his speculative theories on the Mandela effect, position him somewhere between a groundbreaking scientist and an imaginative storyteller. The ultimate value of his work will depend not on how compelling his ideas are, but on whether they can pass the tests of scientific rigor and practical implementation. For now, they remain intriguing concepts awaiting validation or risk fading into obscurity, like many speculative ideas before them. This narrative around Max's initiatives is fascinating, but fraught with the risk of drifting into the realm of pseudoscience, if not grounded in empirical evidence. As we observe his journey, it will be critical to see which direction his theories veer towards: groundbreaking discoveries or mere scientific curiosities. While captivating, his propositions require proof that they have not yet achieved, highlighting the challenge of distinguishing between revolutionary science and mere theoretical exploration. Max's theories, combining quantum mechanics, human cognition, and the idea of multiple universes, suggested a bold concept. Particles could be linked across different universes. These links, he theorized, happened on a very small, subatomic scale and could affect the way humans perceive things, potentially explaining the confusing phenomenon known as the Mandela effect. This theory stretched traditional physics into metaphysics and cognitive science, offering an unconventional and debated explanation for phenomena that, while commonly discussed, remain poorly understood. Back in the spotlight, Max's bold ideas ignite debate among scientists and observers alike, the debate over the collider's cosmic impact. Critics quickly pointed out that while the idea was exciting and fit for a sci-fi story, the real-world applications and scientific basis of such theories often veered into the realm of theoretical physics. Debates sparked within the scientific community, with some researchers intrigued by what Max's ideas could imply, and others dismissing them as imaginative stretches rather than concrete scientific progress. The debate expanded with the 2022 incident at the Large Hadron Collider, when a significant disturbance in the Earth's magnetic field was detected. Initially thought to be due to solar activity, the timing and intensity of this disturbance, coinciding with the collider's experiments, prompted thorough investigations to determine any possible links to the collider's activities. This raised concerns about the safety of such experiments, sparking fears about the unexpected consequences of meddling with fundamental aspects of matter. Critics argued that these concerns illustrated a common issue in ambitious scientific research: the blurring of boundaries between pioneering discoveries and the unforeseen consequences that could emerge from such work. They pointed out that each incident like this added to the ongoing debate about the limits of human exploration and the potential risks involved in probing and altering the very foundation of the universe. Supporters of the collider's research defended the experiments as essential for deeper understanding, arguing that fears of catastrophic scenarios like microscopic black holes were more a reflection of public misunderstandings and sensationalized media portrayals than any real threat. The ongoing debate underscored the challenge of balancing the quest for knowledge with the ethical considerations and potential dangers inherent in such powerful scientific pursuits. Max's hypothesis and the collider incident together highlighted the two-sided nature of advanced science. They not only showed the potential to broaden human knowledge, but also brought to light the practical and philosophical challenges posed by venturing into lesser-understood scientific territories. As discussions continued, the scientific community remained split on the best ways to handle these complex issues, with each new experiment and theory adding to the dialogue about the overlap of reality, perception, and the lesser-known areas of the quantum universe. Every experiment seemed to underscore the delicate balance between pushing the boundaries of what we know and the need to consider the broader implications of our discoveries. This tension was mirrored in academic debates, public discourse, and the cautious approach taken by regulatory bodies overseeing such research. The dialogue about these advanced scientific endeavors showed no signs of abating, illustrating the ongoing human struggle to understand more while managing the risks of profound scientific exploration. However, a recent incident raised concerns globally as it coincided with unusual disturbances in Earth's magnetic field. These disturbances threatened a range of systems, from satellites in orbit to the essential power grids and communication networks that keep our world connected. In response, researchers from CERN, joined by independent experts, began a detailed investigation into whether the collider's activities could have unintended effects on a global scale. Their study was aimed at understanding whether the extreme conditions created by the collider could inadvertently influence Earth's magnetic stability. The question was whether this massive scientific tool could, while attempting to probe the fundamental particles of nature, also be disrupting the planet's magnetic field. The researchers looked into whether the creation of new, possibly strange types of particles during collisions could temporarily alter the magnetic field surrounding us. Given the speculative nature of their inquiry, the review opened up a range of possibilities that caused both skepticism and worry among scientists and laypeople alike. This in-depth examination ignited a wider debate about the moral implications of pushing the boundaries of scientific exploration, particularly when such pursuits could potentially lead to environmental or technological upheavals. The discussions went beyond technical details and ventured into ethical considerations about the responsibility scientists have when their work could interfere with natural systems. The dialogue expanded to include the importance of maintaining a balance between advancing science and protecting the environment that sustains all life on Earth. The concerns were significant enough that they led to changes in how experiments are conducted at the collider. The results of the investigation influenced the implementation of stricter monitoring systems designed to better manage and observe the interactions between the collider's operations and the environment. These enhancements were not only about safeguarding the internal workings of the collider, but were also aimed at preventing any adverse effects on the surrounding natural world. This case at CERN marked a critical point in scientific research. It served as a reminder of the careful consideration required when delving into powerful scientific processes. It underscored the need for scientists to not only pursue knowledge, but also to ensure that their explorations do not harm the planet. The episode highlighted the delicate balance between human curiosity and the responsibility to preserve the Earth's intricate and vital systems. It emphasized the need for ongoing vigilance and thoughtful management of scientific practices, ensuring that the quest for knowledge does not compromise the health and stability of the environment. The experience at CERN thus became a defining moment, shaping future approaches to scientific inquiry and the implementation of safeguards that protect both our planet and its inhabitants. The unsettling event at the High Energy Physics Lab highlighted the urgent need for strict safety measures and ongoing evaluation in particle physics. This incident serves as a strong reminder that our scientific explorations must be conducted with caution, ensuring they do not harm Earth's environment or atmosphere. The idea that technology created by humans could unintentionally change our planet's magnetic field, or even the fundamental nature of our reality, introduces a challenging notion to traditional scientific research. Max's theories push the limits, blending discovery with the duty to protect our world, navigating the boundaries of human perception. Max's theory suggests that subatomic particles entangled across various universes might, under certain circumstances, affect human thinking, leading to experiences similar to the Mandela effect. According to Max, these particle interactions could help explain why groups of people sometimes remember history differently than it is recorded. His theory pushes us to think about the wider impacts of experiments in particle physics, like those at CERN, proposing that they might be having a more direct influence on how we perceive reality than we thought. Linking particle physics to cognitive science isn't a straightforward leap. It mixes what is physically real with what is perceived, propelling scientific discussions into territory that might seem more suitable for a novel. This bold shift expands the ongoing conversation about the multiverse, a concept usually discussed in cosmology and quantum mechanics. In scientific discussions, the multiverse is approached not just as a creative idea, but as a necessary framework to help explain various phenomena we see in our universe. Physicists explore this idea through two main theories, each suggesting different ways multiple universes might exist or interact. However, these theories generally don't consider the immediate human experience, but focus on abstract theoretical ideas. Max's theory, however, challenges this separation by connecting the behavior of subatomic particles to everyday human perceptions. This connection forces us to consider the impersonal laws of subatomic particles and the personal experiences of human consciousness together. This blending of physics and cognitive science not only broadens traditional scientific boundaries, but also encourages a more comprehensive view of our universe, including the outer cosmos and the inner workings of the human mind. Despite the intrigue these discussions generate, they come with a warning. The scientific community needs to ensure that such theoretical discussions remain firmly rooted in empirical evidence. The fine line between groundbreaking scientific ideas and the appealing nature of pseudoscience needs careful navigation. As we attempt to connect different scientific ideas and present them in ways that engage both scientists and the public, we must maintain the strict methods that define valid scientific research. Therefore, integrating cognitive science with particle physics offers exciting new insights into our reality, but also requires a renewed focus on scientific accuracy and ethical practices. As we explore these complex relationships further, the importance of keeping a critical and somewhat skeptical approach cannot be overstressed. This ensures our scientific progress is not only intellectually sound, but also considers the long-term health of our planet and its people. In this extended exploration, the dialogue between different fields of science highlights how intertwined our understanding of the universe is with our everyday experiences and cognitive processes. Each discovery in particle physics or cognitive science doesn't just push the envelope of what we know. It also questions how we know it and what effects this knowledge has on our daily lives and global environment. As such, maintaining rigorous standards and a clear ethical path in scientific research is crucial, ensuring that our advancements benefit all aspects of human life and the broader ecological system. The idea that our universe might have distant areas with different conditions or basic laws of physics is a big stretch for the imagination. This concept suggests there are parts of space beyond what we can observe that supposedly help us understand more about the universe. But one has to wonder, how much do we really learn from thinking about these places we can't reach? A second, equally complex idea comes from quantum mechanics through the many worlds interpretation. This suggests that for every possible outcome of a quantum event, like a particle moving, a new universe is created where each outcome occurs. Physicist Sean Carroll has clarified that our everyday decisions don't create new universes in the scientific idea of a multiverse. In these far-off universes, what we do daily doesn't matter. They exist far beyond our influence. Instead, it's quantum events, not human actions, that cause new realities to branch off. Thinking about personal identity in the multiverse is similar to thinking about identical twins. They start the same but become different people as their lives go on. While the multiverse theory can lead to interesting thoughts about psychology and philosophy, it remains mostly a theoretical exercise. It allows us to imagine different scenarios and their outcomes, giving us a way to think about choices and their effects in a unique, though abstract way. However, in the real world we live in, we can't change past decisions, and we can only affect the future. Getting into the multiverse theory offers new insights, pulling ideas from theories like those at CERN and other experiments. But we must remember to focus on our own universe, where our actions have real results. While based on speculation, these theories highlight CERN's significant role in the scientific world and in capturing the public's attention. CERN leads the way in particle physics, always enhancing the Large Hadron Collider to look into uncommon phenomena and collect data on hard-to-catch particles like neutrinos, crucial for understanding how much matter versus antimatter exists in the universe. The story also discusses Max Laughlin, once called the world's smartest kid, whose disappearance left a noticeable gap in the science community. From a young age filled with questions to becoming a key player in major scientific findings, Max represents a relentless pursuit of knowledge and a deep grasp of our universe. His work, especially in theoretical physics, has pushed scientific knowledge forward. Now that he's back, people are eager to see what new scientific discoveries Max might reveal to the world. Despite these theories like the Mandela effect and the multiverse theory sparking a lot of discussions, they sit on the edge between groundbreaking science and mere speculation. While they enthrall some with their broad scope, others see them as a diversion from science that can be proven through experiments. Exploring these theories shows our ongoing effort to grasp the deeper truths of our existence, even if it might lead us toward unprovable ideas rather than clear scientific evidence. This exploration reflects our continuous desire to understand more about the world, pushing the boundaries of what we know, and occasionally wandering into areas more imaginative than factual. What do you think? Are theories like the multiverse mere speculation or the frontier of science? Like, comment, and subscribe to join the conversation and explore more.